Welcome to homework.
In this problem, we are asked to calculate the x, y and z components of moment that the shaft exerts on the blades as a function of theta. So we need to calculate this mx, my and mz. So let's start by writing the angular velocity. In this case, we can write the capital omega is equals to small omega, and then we can write this small omega as small omega is equals to omega s plus omega p. Where we know that this omega p is equals to omega p sine of theta I plus omega p cosine of theta k. So we can write this omega as omega is equals to omega p sine of theta I plus omega sj plus omega p cosine of theta k. From here we can write this omega x is equals to omega p sine theta, and omega y is equals to omega s, and we can write omega z is equals to omega p cosine of theta. Now let's calculate the angular acceleration of the blade. So we can write capital omega prime is equals to omega p. So this is equals to omega p sine theta I plus omega p cosine theta k. So we can write this omega dot is equals to omega dot of x prime y prime z prime plus capital omega prime cross omega. From here we can write this omega dot is equals to omega dot 1 into x prime y prime z prime plus omega dot 2 into x prime y prime z prime plus capital omega prime cross omega s plus capital omega prime cross omega p. So this can be further written as 0 plus 0 plus here we can write omega p sine theta I plus omega p cosine theta k cross omega s j plus 0. So we can write this omega dot as omega dot is equals to minus omega s omega p cosine theta I plus omega s omega p sine theta k. Here we can write this capital omega is equals to omega, and this omega dot x prime y prime z prime is equals to omega dot. So here we can write the omega dot x is equals to minus omega s omega p cosine of theta, omega dot y is equals to 0, and omega dot z is equals to omega s omega p sine of theta. Now let's write the moment of inertia. We can write Ix is equals to Iy. So this is equals to 1 divided by 12 into the mass, which is equals to 2m into 12 whole square. So from here we can write this one as 2 by 3 ml square, and we can write Iz as Iz is equals to 0. Now by applying the equations of motion, moment equations of motion, we can write sigma of mx is equals to ix omega dot x minus into iy minus iz into omega y omega z. Now by inserting values into this equation, we can write this mx is equals to 2 by 3 ml square into minus omega s omega p cosine of theta minus into 2 by 3 ml square minus 0 into omega s into omega p cosine of theta. So from here we can write the relation for this mx as mx is equals to minus 4 by 3 ml square omega s omega p cosine of theta. Similarly, we can write sigma of my is equals to iy omega dot y minus into iz minus ix into omega z omega x. So this equation can be written as my is equals to 0 minus into 0 minus ix, which is equals to 2 by 3 ml square into omega z, which is equals to omega p cosine of theta into omega x, which is equals to omega p sine of theta. So from here we can write this one as my is equals to 1 divided by 3 ml square and then omega p square sine 2 theta, and sigma mz is equals to iz omega dot z minus into ix minus iy into omega x omega y. Now by inserting values into this equation, we can write mz is equals to 0 minus 0. So this is equals to mz is equals to 0. End of the question. Thank you.